So I'm going to use a spreadsheet to find the regression equation here. To do that, I'm going to highlight. Usually I find it easier to start at the end of the last one and highlight up to the beginning of the title.
Okay.
And then I want to copy that. And then if I highlighted it right, then it should paste in pretty much like it looked there. So I'm just going to try paste. Cool. Every once in a while, I don't highlight it quite right and it comes in weird and I just got to try again. So the first thing I want to do is I want to look at the graph. So with the data highlighted, I want to then insert a chart. And sometimes the computer will guess that I want a scatter plot, and it guessed right. And I'm not going to worry about customizing it for the moment. So there is a slight uphill trend to this data. So I think it's worth finding a line for, especially because the problem said find a line. There's a couple of ways to find the line. I'm going to find it by using the slope formula on the spreadsheet. So I'm just going to put a label here saying I'm going to find the slope. And then in the next cell, I'm going to go equals and start typing slope. And it says find the slope of a line from linear regression, which is what the homework asked me to do. So I'm going to select slope. And the slope command says get the y data first. That's super important that you get the order right. So I highlight just the y values, and then it wants a comma, and then it wants me to highlight the x data. So then I highlight the x data, and then I close the parentheses. And according to the spreadsheet, it says the slope of these points on average is about 3-ish. To get the y-intercept, I'm just going to call that intercept. I do the same thing, equals, I start typing intercept, and I want the one called intercept, which finds the y-intercept for a line derived via linear regression, right? And we're finding a regression line. So then I select that, and just like the slope, it says grab the y data first. And if we get that backwards, it'll give us the wrong answer. It's got to be y, then x, comma, and then x. Okay, so it says, and again, that's way more decimal places than I need. Since this data had 1 decimal point, then I would round each of these to 2, is the typical rounding rule. So if I graph the line, y equals about 3x plus 38.98, that line should look like it goes through this data. If you want to see that line, then click back on the graph and go to edit. And under customize, we want to customize the series, which are the lists of numbers. And if you scroll down there, they have a trend line option. And the line it's drawing right here is the one I just calculated the slope and the intercept for. So now I have my line, and I have in the graph, and I have its slope and its y-intercept there. Now, you can also display some of that information on the graph by scrolling down, and where it says label, if you change from none to equation, then you'll see that 3.01 slope and the y-intercept of about 39. If you need more decimal places, that's when it's important to use that slope command and the intercept command. But for this problem right here, there we go. The regression equation for me to 2 decimal places would be y equals 3.01x plus, I think mine was 38 points, what, it's not 3.8. 38.98. And then they ask for me to use that equation to make a prediction. If a student spent 15 hours on math each week, what would I expect their grade to be? So that's an x value. So if I just plug that x in here, it should give me a y value in this region over here. And I can do that on the spreadsheet too. So for my prediction, I would do equals for a calculation. And again, the formula is y equals mx plus b. So here's my m, my slope, times they gave me 15 hours plus my y-intercept. So according to the slope and intercept I have, I would predict that a student that spent 15 hours per week studying would get a grade of about 84. So here they wanted 1 decimal place. So that would be 84.2. Now, sometimes these problems will also ask for the correlation coefficient. My recollection was the next one did that. That one just asked for the equation, so we would do a regression on those. This one asked for R, which is the correlation coefficient. So if this problem had asked for that too, I'm just going to put a label here for correlation. Generally, the formula you're looking for is a lot like the word we're using to describe it. So if I go equals and start typing COR, there's a correl, which is the correlation coefficient. I'm just going to select that. And like the other intercept and slope, it wants the Y data first, comma followed by the X data. And we just select the numbers, not the titles. So this has a correlation coefficient of 0.9, which is 1 is as high as you can get. 1 means they perfectly line up. These didn't perfectly line up, but this says it's a relatively good linear fit, is what that tells you. And so those are the main things we need to do. Given a set of data, we need to find the slope of the linear equation. If the points kind of line up, we want the y-intercept, so we can have our y equals mx plus b line. Sometimes we'll do a prediction based on the line. And then sometimes we need to know what the correlation coefficient is.